Now I am going to explain about the nucleophilic substitution reactions, that is in alkyl halides. The nucleophilic substitution reactions in alkyl halides are actually two types, that is SN2 reactions and second is SN1 reactions. In this another also there, that is SNI reactions, and fourth one is NGP reactions also there. Now SN2 reactions means bimolecular nucleophilic substitution reactions. Bimolecular nucleophilic substitution reactions, they are known as SN2 reactions, and SN1 means unimolecular nucleophilic substitution reactions. These are known as what here? Unimolecular nucleophilic substitution reactions, and in this case internucleophilic substitution reactions. SNI means internucleophilic substitution reactions, and NGP means neighboring group participation reactions. So these are the four types actually. In this basically main SN2, SN1 you should know, and SNI, NGP also we will discuss. Now we are going to see about the SN2 reactions. SN2 reactions all takes place in alkyl halides, that is what one is primary alkyl halides. In primary alkyl halides, SN2 reactions will take place predominantly. Next is secondary, next is tertiary alkyl halides. So it is the order of the nucleophilic substitution reactions in case of alkyl halides. Now, how this SN2 reaction takes place means, suppose if you take the primary alkyl halides, example is ethyl chloride reacting with the nucleophile like KCN having, that is K plus Cn minus. In this case Cn minus will attacks on the positive charge of the carbon. In this case how it will react means based on the steric hindrance. I means, suppose if you take the chlorine, it is somewhat big group and hydrogens and CH3 group. Now Cl is electron withdrawing group, so partially positive charge will be exist on the carbon. In this case Cn will attack from the back side. Why means, due to the cause of steric hindrance of the chlorine, Cn minus will attack from back side and Cl minus will be released from front side. Why means, already I told that Cl is big group, so due to steric hindrance. When Cn minus is attacking from the back side, then a reaction will take place in two steps, that is Cn minus attacking from back side. First it forms the transition state, that is like this type of Cl minus releasing and Cn minus attacking from. Now what is happening here? Cn minus is attacking on the carbon and Cl minus is releasing, so it is known as transition state. After this a Cn minus strong bond will form with the carbon, then the Cl minus will release from the carbon. So in this case Cl minus will release. So This reaction is takes place in actually in one step only, but rate of reaction depends on the two molecules. How means in this case Cn minus is attacking, simultaneously Cl minus releasing. Means the speed of the reaction, completion of the reaction depends on both nucleophile and alkyl halide. Okay, and in the rate determining step, how many molecules are involving? A rate determining step here, two molecules are involving. How that? The Cl minus, okay, attacking, and Cl minus releasing. So Cl minus relates to alkyl halide and Cn minus relates to the nucleophile. Both are involving in the rate determining step. It is only one step. In that step only, the both molecules are involving. That's why it is bimolecular reaction. It is the bimolecular reaction. Why means alkyl halide and reacting with the potassium cyanide, then nucleophile and alkyl halide, that is primary alkyl halide, both are involving in the rate determining step. So that's why this is the bimolecular reaction, and in this case rate of the reaction depends on how many molecules. Rate of the reaction depends on the nucleophile and alkyl halide, both also. Why means simultaneous happening this one. What is that? Cn minus attacking and alkyl halide, chlorine is removing. So rate of the reaction depends on what here? Concentration of cyanide, and another one is what here? CH3 CH2Cl. Another one is CH3 CH2Cl. So in this case, order of reaction is sum of the exponential terms of the coefficients. Okay, sum of the exponential terms of the coefficient. So that is 1 plus 1 2. It is the second order reaction. Here rate of reaction, how can you find means molecules which can decide the speed of the reaction in the rate determining step. So the concentration of which molecules affects on the speed of the reaction. That coefficients exponents needs to take that some value comes as rate of reaction here, and order and molecularity, how can you decide means in rate determining step how many molecules are involving. So that decides the molecularity of reaction. That's why in rate determining step it is one step reaction. In that transition state, two molecules are involving. So that's why it is the bimolecular reaction. Actually, we are going to study practically the rate of reaction depends on most relates to concentration of cyanide only. Okay, I mean cyanide concentration is more, then speed of the reaction will take place with high speed. Means if you take the potassium cyanide high concentration if you are taken. Now the SN2 reaction actually takes place based on the two cases. One is nucleophile base, one is happening, and also solvent base, another one is happening, and one more you can see leaving group base. Leaving group means suppose here alkyl halide we have taken like this. In this case halide is the leaving group. So this leaving group and nucleophile and solvent, these three can decide the SN2 reaction. Suppose if you take the solvent first, if you take the solvents are how many types here? Solvents actually two types. They are protic solvents and another one is aprotic solvents. Protic solvents means what here? Solvents which can give proton, they are known as protic solvents. Means suppose if you take the water, it is a protic solvent. Ethyl alcohol, it is the protic solvent. So these are gives the protons. And aprotic solvents means they can't give the protons. Example like a stone. Okay, these are the aprotic solvents. So protic solvents, aprotic solvents. Now if you take the protic solvents, then what they will do means they will involve in the nucleophiles and leaving groups. Means suppose if you take the NaCN and alkyl halide. Here NaCN, Cn minus involving in the reaction, and NaCN is the generating the nucleophile. First what happened means protic solvents come, and protic solvents like H2O, suppose H2O have the oxygen and this is negative charge, positive charge. So in this case this negative charge combines with the Na plus. Okay, so it will make solvation like this way. H2O oxygen forms the bond with Na plus here. So this case Na plus undergoes solvation, means it is undergoing dissolving. Same way Cn minus is there. Cn minus will be undergoes the combination, means a bonding with negative positive charge of hydrogen here, means between these two bonds will form. So here Cn minus also undergoes what? Blocking. So in case of the protic solvents, SN2 reaction will be slow. Okay, in case of the protic solvents, SN2 reaction is slow. Why? Means nucleophiles undergoing the hydrogen bond with the H2O, means solvent. So that's why protic solvents SN2 reaction will be slow. Why? Means nucleophile will be not come easily. So here protic solvents case nucleophile is big, then that will form bond with this hydrogen. Means here suppose F minus, Cl minus, Br minus, I minus you have taken. In this case, in case of protic solvents, F minus more than Br minus more than I minus, this way. I means I minus can form the bond with the hydrogen, so it can't come and participate in nucleophilic substitution reaction easily. Okay, so that is one of the case. So here size of the nucleophile decides the what here SN2 reaction, and if protic solvents you have taken, then what happened? Nucleophile is free here. If protic solvents, what I told here, CH3, C double bond O CH3. In this case, suppose NaCN you have taken, and Na plus Cn minus, or NaBr you have taken, suppose Na plus Br minus. Okay, will come. So Br minus is what here? Nucleophile. So Br minus not involving hydrogen bond with H2O, means H2O you have taken, H2O have the oxygen. Oxygen forms bond with what here? Na plus. Why? Means according to charges, this way. But here hydrogen bond not possible to form with Br minus. Okay, so that case what happened? The CH3 C double bond O CH3 will be surrounds around the Br minus, but it will not shows any bond with Br minus. Okay, it will be not formed, so it is free. So nucleophile is free in this case. That's why in presence of aprotic solvents, nucleophile is free and participate in nucleophilic substitution reactions easily. So here, based on the nature of the nucleophile, means strong nucleophile will be more participate in SN2 reaction. Weak nucleophile are possible to participate in SN2 reaction. Okay, so now if you are taken the SN1 reaction, SN1 reaction means it is the unimolecular nucleophilic substitution reaction. So in this case, what happened? Tertiary alkyl halide. Okay, tertiary alkyl halide only participate in SN1 reaction more predominantly. Why? That means suppose if you take nucleophile and solvent, in this case, first in solvent, tertiary alkyl halide divides to what? Carbocation, stable carbocation will give, followed by Cl minus. Okay, now this stable carbocation, okay, is formed afterwards. It is sp2 hybridized carbon, and okay, it is planar, so that's why here Cn minus can attack from both sides. in this case. That is what from front side and back side. So that's why what happened, if that is attacking from the front side, what happened, CH3 groups will come towards the left side and Cn minus from the right side. And if it is Cn minus from right side, then what happened, CH3 groups will go to which side, right side, and Cn minus attacks from the left side. So this case you can get the inversion product. I think you understood what is that. First is tertiary alkyl halide in presence of solvent. What happened? It divides to carbocation and Cl minus. Okay, carbocation, what here, stable carbocation is formed. This stable carbocation, okay, will be involved in the reaction with nucleophile. So stable carbocation is what here, sp2 hybridized carbon, that will be planar, so nucleophile can attack from right side and also left side. So in this case you will get the inversion product and detachment product. In this case this is takes place, means this reaction is takes place in two steps. This is step 1, this is the step 1, and this is what here, step 2. Step 1, what is happening, carbocation is formed. Step 2, what is happening, on the carbocation nucleophile is attached. Means in this case the speed of the reaction depends on what here, step 1 only. I means if the carbocation is formed, immediately nucleophile will attack on the carbocation. That's why the time taken to completion of the reaction depends on formation of carbocation here. What here, time taken to completion of reaction depends on what here, formation of carbocation. That is depends on what here, type of alkyl halide. Means it is takes place in 10 minutes. After formation of carbocation, what happened? Immediately nucleophile will be attacked. So it is in 2 or 3 seconds. The nucleophile attacks on carbocation. So total time taken to complete reaction is what depends on what here, formation of carbocation. So that's why that is coming from what here, alkyl halide. So number of molecules involving in the rate determining step is how many here? Here number of molecules involving in rate determining step is 1. So that's why it is unimolecular substitution reaction. SN1 reaction, what here? This is what here now, unimolecular substitution reaction. Okay, unimolecular substitution reaction. This is nucleophilic substitution reaction. So, okay, rate of reaction depends on concentration of how many molecules here again. Rate of reaction depends on concentration of how many molecules, means first you can check the slowest step in that how many molecules are involving. In slowest step, how many molecules are involving? Only alkyl halide. Only alkyl halide is involving in. So that based on that concentration only, rate of reaction will be decided. So that's why in this case order of reaction is 1. Okay. So this way you can decide the what is the SN1 reaction, what is the SN2 reaction. So SN1 reaction, what happened? Due to the cause of steric hindrance, backside reaction takes place in tertiary alkyl halides, and when tertiary alkyl halides dissolved in solvent, what happened? Stable carbocation will be formed. Now you are going to see effect of the solvent in this case. Solvent. So solvent, what does it should make the solvation of the what here, make the solvation of what here, alkyl halide. Alkyl halide, if it is undergoes more solvation, means it divides to minus and plus, then reaction takes place immediately. Okay, so actually solvents are two types. One what you told, protic solvents, another one is what here, eprotic solvents. Eprotic solvent, and another one is what here, protic solvent. Two types of solvents are here. So if you are take the protic solvents, protic solvents, what you are taking, like H2O. If you are taken, then what it does first, okay, it will be divided. Suppose alkyl halide divided into carbocation, okay, alkyl halide divided to carbocation plus Cl minus. That Cl minus will be bonded by what here, H2O, what positive charge. Cl minus will be surrounded by this like H2O positive charge. What it does, surrounded by Cl minus. So that's why Cl minus means solvation undergoes easily. And afterwards, nucleophile is free in this case. So nucleophile will be attached on the carbocation easily. That's why in this case, what you can decide, SN1 reaction can takes place in the protic solvents more and more predominantly than aprotic solvents. So in this case, suppose if you take the HI, HBr, HCl, HF. HI means conjugate nucleophile, conjugate base is I minus, conjugate base Br minus, conjugate base Cl minus, conjugate base F minus. So in this case, strong nucleophile means strong nucleophile, what comes means I minus comes, then Br minus, Cl minus, F minus. Why means it can donate the electrons more and more easily. Okay, this way you can decide. So the strong nucleophile, what comes, that can be participate in the nucleophilic substitution reactions easily. So if you take the other cases, suppose the CH3OH, CH3OH, CH3OH and CH3CH2OH. This way I have taken. In these two, weak bases, weak acid is what? Weak acid is CH3CH2OH. So this is the strong base. Why means weak acid conjugate base is strong, so it is strong nucleophile. Other case CH3O minus. This is what here, strong acid. That's why conjugate base is weak. That's why conjugate base is weak means that is the weak nucleophile. Base is strong means that is what here, strong nucleophile. That's why you can define that strong acid conjugate base is weak, so that is weak nucleophile. Strong weak acid conjugate base is strong, that is strong nucleophile. So first you are going to define order of nucleophilicity. You should know about the acidic character. How can you define that? Strong acid is there means, suppose if you take the CH3COOH and CH3OH. In these two, strong acid is CH3COOH. So this conjugate base is what, weak. So in this case, CH3COO minus is weak base and CH3CO minus is the strong base. So it is strong nucleophile than this one. So this way we can define that, okay, order of nucleophilicity. So these are what here, SN1, SN2 reactions. Okay, thank you.